Can you hear me? Yes. Cool. Thank you. Welcome. Good morning, lovers. Before we start with the actual talk, I would like to tell a small story first, right? And I'd like to borrow a concept from physics, and I would like to start talking about acceleration, right? Acceleration is the rate of change of the velocity of an object with respect to time. And when we transport that concept to things like technology, we can see that 100 years ago, we were evolving at a much slower pace than we are innovating now. And when we think about the internet era in the 90s, we can think there was an explosion, right? Currently, we have lots of things from search engines, the Wikipedia, applications like global streaming, Netflix, Spotify, and so on and so forth. And also in the 90s, when this software exploded, we were releasing mostly once a year, every software, right? So there was the version 95, the version 96, the version 97, and so on. Who was building software in the 90s in this room? Is it anyone? Okay, a few faces here. I'm sure you remember those times, the big release of the year. Currently, that's not the case anymore. Software is deployed on demand. Software changes every day. It changes every hour. And even there's lots of A/B tests running in each of the applications that we deploy every day. Let's talk about the situation that you know more than me, right? I'm a happy Glovo user. And when I tap order on my Glovo application, this is the moment I like the most. The moment when the courier knocks on my door and he delivers a great hot meal so I can enjoy it with my family. And relating this to acceleration, from the time that I hit order until the courier knocks on my door, there's a lead time, right? And I'm sure that if I could accelerate this lead time from order to delivery by 10%, I'm sure that Oscar Pierre would drag me from this stage and we would have a very interesting conversation about how we could make more millions in revenue for Glovo. Now, the real thing. Can we do something to accelerate software development teams in our daily lives so they deliver more value faster? What would that something be? This is what I'm going to talk about today. I'm going to talk about the journey that the Adevinta platform team is doing on accelerating large engineering software teams to deliver more value. Before, a bit about me. I'm originally from Portugal. I come from a really small town of 800 inhabitants, and I've been in Barcelona for the last 7 years. Mostly as a software developer with focus on distributed systems, and more recently building and scaling teams as an engineering manager, previously at My Taxi Free Now, and now in Adevinta, the company behind Mil Anuncios, Fotocasa, and other marketplaces in Spain. I love internal developer platforms, and I'm sure that in the Q&A and afterwards, we will have a lot of time to talk about those. Warning, although I'm the one here today in front of all of you to talk about this internal platform journey and how we are helping teams deliver more value, there's a lot of people behind all of this, right? At least 4 teams and 50-something engineers working on this nowadays. And what I also hope with this talk is that they are inspired to be the next ones to talk about this in front of people, so I can just retire from public speaking. Okay, the last 10 years, there was a revolution on how we were shipping software. I remember that companies were running in data centers, fighting with capacity planning, virtual machines, and lots of complicated stuff. And the public cloud with Amazon Web Services and Google Cloud Platform and others, they empower teams to be much more autonomous. What also happened is that with this advent and having access to tools like code review with GitHub and other software as a service, there was this need to allocate part of the engineering resources, not only doing product development, but also taking care of this infrastructure. Some companies, they were calling these teams core teams, infrastructure teams, and for the sake of this talk, we are going to talk about platform teams. So this is the framing that we are giving it here today. And a bit of context on all of this is that about Adevinta, right? And this will be relevant later in the talk. Adevinta was an offline company not long ago, less than 20 years ago. And when it became an online company, it started with a second-hand marketplace in Norway. And through mergers and acquisitions, it became multi-company, more than 20 brands, more than 1,000 engineers working on different products. And as you might imagine, having all of these companies with their own tech stacks, with their own continuous integration, continuous deployment tooling and whatnot, these make the teams invest locally and in sharpening their tool set. And we were not actually leveraging the scale of the company, right? I just said more than 1,000 engineers. So every local team, they were taking local decisions and they were sharpening their tool set locally. So how could we improve the engineering effectiveness from a global point of view? This was the question that and the general framing for all of this. Engineering effectiveness. Oh my God, such a hot topic. Do you remember those times where people were measuring engineering efficiency by counting the number of lines of code that people were shipping? Who remembers this? I hope we are not doing it anymore. Such a bad thing, right? I hope we are counting the lines that we are deleting. But more seriously, when we define engineering efficiency, we need to take a look and take a step back and see what does that actually mean. And that's where there's a lot of literature in the industry. Today, I'm going to talk about Peter Seibel, a former CTO of Twitter, and also David Jarrett, engineering director at Adobe, and how Peter explained this model that relates engineering efficiency with the product teams and also the platform teams that in the company. So the model goes like this. The overall engineering efficiency is the number of total engineers we have in an organization minus the number of platform engineers. So far, so good. This looks reasonable. And this is multiplied by a boost factor that these platform engineers give to the product engineers. And it's also scaled with a law of diminishing returns, meaning that the 10th engineer that I add into a platform team will give less value than the 9th, that will give less value than the 8th, and so on. To make it more visual, we have here the stream-aligned teams on the left. And if we invest some of the engineering workforce into boosting the productivity of those, we will get the expected gains in engineering efficiency. Of course, this is just a model, okay? And different companies, they are different sizes and there are different contexts. So the boost factor, the amount of gains you have by putting another engineering in the platform team varies from company to company. And it's the same is true for the scaling factor, right? So David Jarrett in a different blog post, he does a small exercise that for a 1,000 engineer organization, with the values he chose for boost and for scaling, he ends up concluding that perhaps 25% of the total engineers should be allocated to work in the platform so they can benefit from a boost in their productivity. Okay, efficiency. What else is the industry telling us? There's these two folks, Matthew Skelton and Manuel Paes, and they are studying the Conway's law, right? So the law that tells that we end up building software the way our teams are organized. And After studying this, they published this book, Team Topologies, where they define 4 types of teams in the context of companies that deliver software. And one of the teams they define are platform teams, right? Aside from defining them, they also make a special difference between these platform teams and the old infrastructure teams that we are used. And I will explain it now. So these platform teams, they have interactions with product teams and other teams in the company, mainly by providing things as a service, right? Not through ticketing, not through, please create me a database in this AWS region, through things as a service that people can consume on their own. And this is really important because this makes a difference when we are treating a platform as a product, right? As something that can be consumable rather than we are blocking people from getting their infrastructure up and running. In the most recent ThoughtWorks Tech Radar, we can also see this trend, right? So more and more, there's a recommendation to treat platforms as products. And there's also a recommendation to adopt the 4 key metrics that we are going to talk next. Who knows the 4 key metrics in this room? Anyone? No? Okay. So the 4 key metrics is the result of a scientific study conducted by Nicole Forsgren and her research group, the DevOps Research Assessment Group. And they conducted this at large scale with companies that primarily ship software. And what they found out is that there are 4 key metrics that link high-performing software engineering teams with business outcomes. And these metrics are how often we are deploying to production, what is the time since I commit a change until it reaches production, together with 2 metrics that they are used for quality control. The mean time to recovery, since there's an impairment in a service until we fix it, and also the change failure rate, which is out of all the things that go into production, how many of those are to fix an actual problem, right? And they went a step further and they categorized software teams depending on how they were performing on these metrics. So they categorized them in low, medium, high, or elite performance. And to give you a glimpse of this, and a team that's an elite performer usually deploys multiple times a day. They take less than 1 day to move a commit from commit to production. They have less than 1 hour on mean time to restore a service, and their change failure rate varies between 0 and 15%. And why does this matter, right? So there's more or less a scientific way to measure software engineering organizations that's linked to business, right? And this is important. There's a correlation between this and business metrics. And there's also a trend in the industry where more and more software teams, they are becoming elite performers. This means that more and more software teams are deploying every day, and they are deploying constantly their changes to production, meaning that the teams that are laggards and they are in the low performing, they will be in a worse position to keep up to date with their software and delivering product to their users. And this is basically why we decided to build an internal developer platform. We call it the Common Platform, and this is the homepage of the Common Platform, and you can see what it stands for. We want to deliver more value faster. That's pretty simple, right? That's what we've been talking about in the last couple of minutes. But delivering this is not that easy, right? Because every time I talked about platform teams or core teams with different engineers, there's always this idea that these folks are like elite teams that they can do whatever they want. They are ivory tower architects that they decide everything for everyone in the company. And usually people get really frustrated about all of this. So in order to develop efficiently our internal developer platform and to make sure that it's catering to the needs of our engineers, we define a series of principles that guide how we evolve our platform. First principle, treating our platform as a product. This means top-notch documentation, tutorials. This even means that we have a proper help center with clear service level objectives, that when something is broken in production, we get a response to a team in less than 1 hour, for instance. This means that we involve our customers into new feature requests and new development, because that's the only way we see the platform evolving. We believe in the Pareto principle, having a golden path and making the right thing the easiest thing to do, right? We recognize that we can't cater to all the teams across the company, but we strive for 80% of them. 80% of them need to have their microservice up and running with a TLS certificate and a DNS. That's it. So we define the golden path and we make it the easiest thing to do. Of course, when you talk to engineers, there's always a discussion about what's the right thing to do, right? So we pick one and we stick to it. Important, we are toil absorbers. I'm not sure how familiar you are with the concept of toil, but toil is this grunting work that no one really wants to do. Things like upgrading libraries, upgrading Docker images, and migrating from system A to system B. No one really wants to do that because it's void of value to the company. And usually people find it a really time-consuming activity that doesn't give anything for them. So we recognize this and we want to automate this away from the teams as much as possible. So we don't want to export this toil to our teams. It's all about the glue and the user experience. We are not here to compete with Amazon. We are not here to compete with other companies that provide really good cloud services. We are here to make sure that we integrate them together and that we bring a good experience to our engineers. For instance, we are not here to create the best metric system in the world. We are here to make sure that we integrate that metric system with the workloads that our users already have, right? So they have an end-to-end integrated experience. By the way, we also have people that are experts in user experience and user interfaces inside our companies, right? It's not just software engineers building things for software engineers. We acknowledge that we need people that are experts in user experience. Like I said before in the acceleration introduction, the world has been growing exponentially, right? So people are leveraging each other's technologies in a way that we are much more innovative than we were 50 years ago. This is the same principle that we want to apply to our platform. We want to build the right set of APIs so people can build on top of them and they are not blocked by us, right? The thing about creating a ticket versus using a self-served API so I can build on top. So I'm unblocked by default. What we also know is that we don't know how infrastructure will look like in 2 years, but we know that it will be different. We know that 10 years ago, we were running mainly virtual machines. We know that we are running containers now, and maybe in 2 years, we'll run functions or we will run low-code applications, right? We don't know what, but we know that things will change. Therefore, we need to be prepared for this change. For instance, we have some products that we created in-house that 3 or 4 years ago, they made sense because there was nothing in the market that you could just buy and use. But now perhaps they are lagging against these products. So we need to be prepared to decommission things that we created before and evolve with the industry because this is the right thing to do. And because this also creates cognitive load for our teams. So important to mention that migration should be transparent for our users. Like I said before, people don't come to work every day to migrate from Kubernetes 1.15 to 1.20 because that gives no value. And when we ask people things like, look, on January the 1st, you need to migrate your thing from system A to system B, people people start going, oh my God, not again. And we try to apply this with the concept of no migrations. The platform evolves underneath the engineer's feet. And the last guiding principle is that we believe in the thinnest viable platform, meaning that instead of having a broad set of services that we ship to our engineers, we make sure that we have a thin layer, and that thin layer is good, usable, and is reliable. It's preferable that we have good documentation that doesn't mean a big engineering investment, rather than have a really broad platform. So we talk why we are building this internal platform, and we talked how we are building this internal platform. So what is this internal platform about? As said before, we tend to focus more on the capabilities of the platform rather than the implementations themselves. Why? Because implementations will change. What today is cool, Kubernetes is quite cool, maybe tomorrow is not cool anymore, and we need to be prepared for that. So the capabilities we have, they are around automation. So we automate things away like releases for developers, rebasing, Git branches and whatnot, continuous integration, and artifact storage with code quality, continuous delivery, runtime. This runtime is based on Kubernetes with our own opinions on top. Everything is linked together with observability tools for metrics, for log collection, and more. We have a quite interesting concept, which is insights, that we are going to talk about in the next 5 minutes. And everything is wired together. So when there's an incident, we have an incident management system that we can use to run the incident and run incident reports afterwards. What's the engineer journey in the company, right? So based on these capabilities, people, they commit code to GitHub regularly. There's automation on top for asking for pull request reviewers, rebasing and whatnot. All of this is built in Travis CI, and it's checked against a code quality tool. Things go through an artifact storage, and then they get into the continuous delivery pipeline. In this case, we are using Spinnaker, which is an open source project from Netflix. And yeah, this is important. In our platform, we took a decision based on the thinnest viable platform, which is we allow people to run stateless workloads in the platform. If people need state, if people need a database, if people need an SQS queue, Redis cache, they can do it. They can ship it with infrastructure as code, and they can talk with those things, but it doesn't run on top of our platform. Why? Because we know that stateful workloads, they require another set of capabilities that we are not prepared to provide yet. So we prefer that these things run on the cloud provider directly. Then all of this gets shipped into Kubernetes. That's wired already to logging, metrics and stuff, right? So if you create a new microservice today, out of the box, you'll get metrics, logs, and you will get even a dashboard where you can see some health metrics for your application. Okay, before I talked about insights and how that's important for us, and now that we are talking about how we are building all of these things, it's important to have an enabling architecture. I talked before about glue and user experience, and this glue and user experience is powered by having access to the whole flow of development from code to metrics and whatnot, and that we are collecting events of all of these things at each of the steps. So we collect these events into an event bus that we call DevHose, and then we can derive facts from those events. What kind of facts can we derive? Cost insights for teams. Teams can get at a glance how much they are spending on top of Kubernetes. What else? They can see how much they are, how much their builds are taking, and take decisions based on data, right? Are the builds taking slower and slower and slower? So maybe the team needs to focus a bit on the build time? Maybe yes. Or even, we talked about engineering efficiency. And one great thing of having everything wired together is that any application that jumps into the platform, they get out of the box the 4 key metrics from Accelerate. No questions asked, right? And this is extremely important because the metrics by themselves, they don't solve any problem, but they are a great Kickstarter for conversations inside the team. Why are we just deploying our service 1 time per week? Is it because we lack testing? Is it because our technology is outdated? And this drives the proper conversations. The 4 key metrics, they are not about the metrics themselves. It's about kickstarting these conversations and talking about the capabilities that enable to be an elite performer. Okay, so far so good, right? So everything is wired together, great user experience, end-to-end, glue, UX, fantastic. But I told before that Adevinta is mostly a merger and acquisition shop, right? So lots of new companies come and go from this huge company. And one thing that happens with that is that they come with their own legacy. They come with their own baggage. So what happens when they come with their own baggage and they need to jump into this internal platform? Do they need to refactor all their code and put everything together to run on top of it? The answer is no, right? We have escape hatches where people, they can hook parts of the internal platform and leverage the great parts of it while retaining the flexibility of running the things that work for them. Let's go for a more concrete example. So as I said before, any application that runs on top of the common platform, they get their logs shipped to a certain logging provider that I'm not mentioning because this is not the case here. And we had a marketplace from Italy, Subito, that they were running their applications in their data centers, in their AWS accounts. And they said, look, folks, we want to try the common platform and we want to put some microservices running on top of it. Cool, right? The thing is that they were using a different logging provider, and what they didn't want is to have 2 different logging providers, because that's a mess to debug, right? When something goes on in the services and you need to jump from Kibana to SumoLogic or to Datadog, and it's really messy. So this is what happened. We were not prepared for that, right? But what it allowed to us to have this conversation with them is that we understood that we need to create a set of clear APIs where people could leverage in these joins, right? So this join that ships logs from our container runtime to a logging provider should be a public API that if someone needs to run a legacy logging provider, or if they are not satisfied with the provider we choose, they can hook into another thing. We talked about escape hatches, and one of the biggest parts of having this internal platform is to create multiplier effects, right? So if we can get more and more applications running inside this platform, a smaller change in the application that runs across the fleet will have a bigger impact. What does that mean in practice? So last July, we decided to migrate to a new logging provider, right? It was cheaper, better, whatever. And we had the opportunity to do a back of the napkin calculation on what was the effort to do it inside our internal platform versus the teams that are running their workloads directly on top of AWS. We can see that we had more or less comparable size of applications, 250 in the common platform and 174 in running the AWS directly. And here we can start seeing the difference. 0 pull requests done in the common platform against more than 200 pull requests done outside of it, because you need to set up the logging agent, you need to test it all together and whatnot. And then you can see what is the result. We estimate that we spend 1.3 person hours per application inside the common platform against 20 hours 20 person hours per application outside of the common platform. And this means that the common platform was 15 times cheaper when it came to migrate this logging solution. And this is really key in these kind of things, but because as you know, more and more cloud providers are invading each other's space, either for logging or metrics and whatnot, and this gives a lot of leverage to the company. If we can make so cheap to migrate applications from one logging provider to the other, our company can be much more aggressive negotiating with the cloud providers. And this is really huge. However, we have an engineer working with us that he always tells me, look, it's great that we save costs, but costs are not the only reason we are building an internal platform. And he's totally right. There are other things where we can see multiplier effects that they are not necessarily just saving costs. This is something that we shipped, I think, in the last month, which is that every application that's running inside our internal platform, from one day to the other, they got access to their critical security issues, like that, bam. Before, we had a security platform that would do that for them, but they needed to wire everything together. The advantage of having applications running in such a platform is that from one day to the other, they get this out of the box for free without any work. Right? And this is amazing for departments like security, because instead of enforcing policies and putting deadlines and asking people, hey, did you already have security scanning in place? We can just do it for them. What other multiplier effects do we expect in the future? There are some that are related to cost reduction, like exploring architectures other than Intel's, or even whenever we put a new instance type on top of our Kubernetes clusters, people, they benefit out of the box from their workloads to being cheaper to run, but there are much more. Okay, I talked a bit about effectiveness. Then I talked about why we are building the platform, how we are building the platform. Then what are the advantages of having such a platform in place? And now let's talk about some lessons learned, right? Because not everything is just cool things and things that went well. There's lots of learnings and lots of storms that we passed through and that we still are on them. And let's talk about a couple of them, and then we can go to the Q&A session. The first lesson learned, we have a huge portfolio of things. Our platform grew too big. We have some internal tools, or we operate some open source software ourselves that currently it doesn't make sense that we do it anymore, because there are standard solutions in the industry, or there are things that got commoditized either by AWS or by GitHub or by all these companies. And we need to be smarter about the things that we keep in our portfolio and the things that we let go, right? And so far, we were not that good on that. And this created a lot of cognitive load on top of our teams, right? So our teams needed to understand a lot of tools in order to deliver this experience to the users. And we need to reduce this cognitive load to an acceptable level. This is also great. We had one big Kubernetes cluster for the whole company. Best idea ever, right? No. A huge, big single point of failure with a huge blast radius. If we took down that cluster, we were taking down bits and pieces of all the organization, and that was not really cool. This is what happened. We ended up firefighting a lot, and having this huge blast radius, it created fear in our teams, right? So our teams were fearing adding new feature to our Kubernetes clusters, and everything got slower because as teams got fear, they were testing more and more changes in bulk, which created a perverse effect of having bigger outages and whatnot, right? So what we learned here is that we needed to start partitioning the way we were scheduling the workloads. So currently we are aiming towards having more clusters, lots of them, and having an equilibrium in the blast radius that we allow, right? So if we take one of these clusters down, we are not taking the whole company down. And last thing, we learned that for operational efficiency of our own teams, we need to start treating Kubernetes clusters as disposable face masks, right? We know during the pandemic, this is good for hygiene reasons. And also in engineering, this is good for hygiene reasons. This is good because then we don't treat clusters as special snowflakes. We don't do special configurations on top of those. And we do this because then we are going to be able to iterate much faster the features and the capabilities that we have on top of our Kubernetes clusters, right? So this is one of the main lessons learned on this journey. So this is it. We build the common platform and this internal developer platform because we want to increase engineering efficiency. We are building it as a product because we want voluntary customers to jump on top of it because it provides value to them. And then we learned a lot and there's a lot of growing pains with us. Let's recap. Engineering efficiency, the 4 key metrics, right? They are linked to companies that have better business outcomes. Treating platforms as products and focusing on the glue and UX. It's not our job to compete with AWS, with Grafana Cloud, or with Datadog. It's just to glue everything together for our developers. Having such a platform drives multiplier effects and economies of scale. Remember, we changed the logging provider in less than 2 or 3 months with a lot less effort in the applications that are in the common platform against the applications that run on top of bare AWS. But of course, as with always, there's a lot of growing pains, especially because the teams that are building this platform, they were usually far away from product development teams, and we don't have in our tool set things like cheap failure cheaply, right? Making sure that we can A/B test new things, making sure that we can make the blast radius really small, like our product development teams have. So we are still building this mindset inside of our teams. So I'm opening now the stage to any questions that you might have. If you don't want to ask now, we can always have a coffee later and we can talk about internal platforms. I wanted to thank you, especially Paolo, Dimitri, and all the organizing teams. Thank you for having me today and have a nice day.
Sure. There are questions in the Q&As on the webinar from Samuel Baena. So he's asking, how long did building the platform take? How flexible is your platform? What do you support? Services, single resources? And then he's also asking, can developers do anything infra-related outside the IDP?
Okay, lots of questions in that question. First, before we build this cohesive platform, some of these services were already built in the company, and it was a matter of productizing it and gluing them together, right? So I must say that as the common platform exists right now, I think it's more or less 2 and something years, almost 3 years. But some of these components already existed before. Then the second question, how flexible it is? It depends, right? But as I said, we try to have some clear APIs so people don't need to use the whole platform as a whole, and they can use bits and pieces of the platform. And regarding infrastructure, yes, people can do infrastructure outside of the IDP. They are free to do so, right? Actually, one of the key characteristics of the common platform is that it's based on voluntary usage. If a team doesn't see fit to run their workloads on top of it, they can always run their workloads wherever they want, or they can run their builds on a different CI solution. It's up to the team. But what we try to make sure is that it works for 80% of the cases, right? We try to make it the easiest thing to do, but teams are autonomous, of course.
And there was another question from Javier Lopez Nieto. In the platform team, we have been thinking of building a type of common platform for provisioning services and infra. What would you recommend us to focus on the beginning, coming from zero? Should we build it ourselves or adapt on already built solution?
I'm going to default to the basic software engineer answer. It depends. I'm sorry for that. No, but more seriously, right? So this topic of product as a platform has been getting traction in the industry. And it's what I would recommend first is that you analyze exactly what you have already in place and what are the needs that you are trying to cover, and adopt a product mindset, right? So MVP, you can try something. There's things like Backstage, created by Spotify, which is a framework to build platforms on top. And you can try with that, or you can try with your own ideas, check with a small set of potential users and see what sticks and what stinks, right? So see what makes sense for them and what does not. And this is the most important lesson, I think. It's not just about what do we want to build or the cool things that are there, is who are we serving, right? Who are our users and how will they use this and how can they get the most advantage of it? So this is, I think, the best advice I can give.
All right. Any other question in the auditorium? We have, okay.
Hey, so how far are we from? No? Yeah. How far are we from seeing this kind of common platform tools being shipped as products, like outside of, so these are being built by different companies like Adevinta internally, but how far are we from seeing these as products that are kind of open source for any company to use in a similar fashion?
I think we are already seeing them, right? There's a company called Humanitech that they tried to do exactly this. They tried to create a pluggable system where people can build internal platforms on top. One thing that's important about productizing this kind of internal platform is that for big companies, so I think Glovo qualifies as a big company now because I've heard that you have 500 engineers right now. It's difficult that there's a solution that does it all for you, right? Because if that's the case, and there are solutions that they can provide great parts of the experience, then maybe there's one bit and piece that it's extremely expensive. For instance, metrics may be extremely expensive on this service. And then you get the question, how do I get out of this metric system? And this might be true for several parts of the systems that you are using, right? And when the company then wants to optimize costs or wants to optimize for a new experience for developers, for instance, going from using Prometheus and logs to using a more SLI, SLO approach like Honeycomb. How can you make this without breaking the whole ecosystem, right? And therefore, I find it difficult that someone from the outside can know your company and your developers so well that can cater to this Pareto principle so well. It might be the case. I'm not saying this won't happen. There are companies that they are trying this, and let's see how that plays.
Hello, we have 1 more minute. There was another question somewhere. Raise the hand. So.
Thanks. Very nice talk, first of all. I wanted to ask you about cost transparency in your runtime as a product. Are you providing, any metrics in there, cost visibility for teams, maybe at the Kubernetes service level? And how are you making sure that teams are provisioning optimally, for their resources?
Great question. So yes, this is exactly what a team can see on their services running on top of the platform. They have cost transparency, and we even every month we send an email to the teams with their costs, where they can see how can they optimize their costs in regards to infrastructure. There's a lot of work to be done here yet, right? For instance, we know that there's a lot of over provisioning, as we know there's a lot of things to do in development environments or pre-production environments. We want to make sure that we give the teams the right tool set for this, like vertical auto scaling or scaling into horizontal metrics different than CPU or memory. We are not there yet, but we are aware that this is a need from our teams, and we want to take it from there.
Thank you, Joel. Let's give him a big applause.